This lesson is about introducing some randomness into your game. Commonly we find that there's a big issue with the predictability of playing games. A lot of the time, whenever you encounter any game, you'll find there's a very large proportion of it that is quite linear and things happen exactly the same way every time. So that's fine. I mean, it does give an ability for you to have a little bit of gameplay. If you look at Mario, for example, you can guarantee that when you play Mario that everything's predictable. You know, you're going to walk along the map and at a certain point a certain platform's going to appear and a certain thing's going to run across the bottom of the screen and you can jump on it. And it always happens in the same sequence. Everything's triggered. It's based on where you are on the map. And that's fine, that's okay. I mean, it makes the gameplay very good for a lot of games, but sometimes you want a little bit more difficulty, and you also want to sort of maintain the player interest. You know, you don't want it to be the same all the time. So we need to be able to create randomness. Now, I'm sure you're already aware that an actual true random number is not possible in a computer. You can't do that. All you can really do is you can work on the idea that we can use a random number algorithm which gives us something that appears to be random. Normally that works with some sort of seed value, some value to start this calculation off to give you a random number. And in XNA and probably most C# applications, when you do random numbers, you tend to use it based on the system clock. So the current time that the computer's being running, because that effectively has an element of randomness itself. It means that you start off in a different sequence when you start with your random number generator. But that's done automatically. What you need to be able to do is you need to be able to do that in code. So for an XNA game, what we do is we create a random number generator, and I would advise you to use one random number generator for all the things that you're going to do in your game, because that will guarantee everything behaves differently. So to do that, the first thing is we're going to start off with the main game class. Okay, so if you look up on there, it says public game 1. Not the best name, but it will do for the moment. And as normal, we've got all the normal stuff that we had before. Now this short tutorial is really based around the fact that you've just done the delay class in the previous tutorial. If you haven't, I would suggest you go back and do that one first before you attempt to do this one, because there's two things that are involved in this. So first of all, we need to create this random number generator. Now we do that by simply adding in a random object. Okay, so the moment you create this random object, it gets initialized. Okay, and as it says there, it gets initialized using a time-dependent default seed value from the system clock. Right, so we've got this new random number generator called rand. It's obviously an object. We've created it from the random class, which is part of the framework that we use when we're working with XNA and with .NET. So, what do we do with it? Well, first of all, we have to make it available to everything in our game. So, we make it public, so that means that it's visible to any classes that we want. And we make it static, which means there's only one instance of it. Now, you may or may not be aware of how static works. So as a very brief indicator of how it works, because this is public and static, it means it's what's called a class variable. That means you don't need an object to use it. Okay, so we will be able to refer to game1.rand, and that will actually allow us to access that variable from anywhere in our program. It doesn't matter whether it's in a different class or not. So that's given us a random number generator, and every time we call something from this random number generator, you will find that it gives you a random number, and you will also see that there are different ways that you can make that work. For the moment, we're going to work with floating point numbers, because we're going to use this random number generator to first of all set the direction of a sprite, so it will set off in different directions depending on what random numbers it's given. And direction, as you know, is a vector 2, and a vector 2 takes floating point numbers to allow it to identify the movement in the x and the y. So I haven't done anything really any different to what I normally do. We're still in this situation where we've got an enemy sprite and we're setting its position. we've got its radius, which we're not using at the moment, but will be used for collision detection, and we're adding it to the game component. So we know its update method is going to be called automatically. The next stage is actually to put something in enemy sprite that makes it move randomly. So what we have here is, this is very much what we had from the delay class example. We've still got this movement delay, timer done, game time. This time, because we're not having a pause in its movement, base.update gets called all the time, so we don't need that moving really. We're still using stay on screen because there's obviously not going to be much use for it to be disappearing off left and right every time it moves off randomly. But what we need to do now is we need to add in the code that adds this randomness. So the first thing we're going to manipulate is the direction. Okay, now if you remember, that comes from abstract sprite, if you weren't aware. So I've done the code already. I'm being a little bit of a cheat by using the undo methods to speed the process up, so you can concentrate more on what I'm talking about rather than me typing. Right, so let's start with the very basics first of all. Direction X and direction Y are floating point numbers. So what we're doing here is, this is a cast. That means that whatever is in these brackets will be converted to a floating point number after the calculation is done. Okay, so that's the first thing. That's how we're ending up with X and Y being floating point numbers. If you didn't put that in, XNA and Visual Studio would just say can't automatically convert it to a float, are you missing a cast? So that's what that brackets float means. Next thing, remember I said that this was a public static variable, rand, yeah? So because of that, that makes it a class variable, so we refer to it by class name, game1, which is what our XNA game was, and then dot, and then the variable name, rand, and then this is a built-in method of the random class. Okay, next double, it returns a double value, alright? Okay, and as you can see when you hover your mouse over it, a random number between 0 and 1. Okay, so the obvious thing to say is that if I wanted this to move at a reasonable speed, so it might return a value between 0 and 1. What I actually want to do is I'll double it first. Okay, think about your BODMAS, so multiplications first. Okay, you're going to say, why do you do that? Well, because if you think about X and Y and direction movement, what we actually want it to do, we want a random number between +1 and -1, so it can move not only from to the right, it can also move to the left and up and down. Because 0 is in the middle, isn't it? No movement. +1 is moved to the right, -1 is moved to the left. Okay, so we multiply it by 2 and then subtract 1. Alright, so that gives us a number that is basically between -1 and +1. Then, because I want it to move a little bit faster than that, because enemies are a bit boring, a bit easy to move, and you can hit them fairly easily if they're only moving at 1 pixel at a time. So I'm multiplying the end result by 2. So actually we end up with a bigger value. And we use that for X and Y. So at that point, that means that the direction will change based on when this timer is done. Okay, so we're happy with that. That's a very simple principle. We're happy with that. I've increased the speed that it changes. Alright, so now our delay is at 0.2 of a second, so we get a change in direction every 0.2 of a second. So that works. That will do. Every 0.2 of a second that will happen. But that still doesn't give it enough randomness in my point of view, because it's predictable that it's going to change direction every 0.2 of a second. So what we can also do is we can also add in randomness on the delay itself. Okay, so now what we're doing is we're using next double again, but now we're multiplying that by 3 and we're using it to set the delay. So every time the timer runs out, it resets that timer with set delay, and it gives it a random number. Okay, so that's quite useful. That means that at that point it doesn't only change direction randomly, it also changes the amount of time before it changes. And that's it. That's really simple. It gives us the ability to have some randomness in our game. Alright, it makes it a little bit more interesting for the player. It makes things unpredictable. Okay, and it's quite a simple thing to do. There's much more you can do with random numbers. You can, randomly create how many things appear on the screen. You can even randomly put a delay how often things appear on the screen. So, we could use it as a random for how often the enemy fires a bullet, for example. Right, so if we run that, what should happen now is our sprite will appear on the screen, and then randomly it will change direction, and it will be at different amounts of time. Obviously, because I've multiplied by 3, the most it will be is 3 seconds before it changes direction. Okay, so if you're thinking about a value between 0 and 1, okay, and there's our sprite, and if you look, slowly but surely it's going different amounts of time. There's a longer one, short one. Okay, and it's truly random. I can't predict whether it's going to move a little bit or a lot. Okay, so, and that's the basic principle. You can see it doesn't bounce off the screen because it's not letting itself go off screen simply because I've used the keep on screen method that I'd already created. And that will continue onwards. So what you're looking at there is every time that changes direction, that means that the timer's up, and then obviously the direction that it chooses to move is by the random numbers. So in summary, if you want to use random numbers in your game, the first thing you need to do is, in your main game, right up at the top of the class, create a public static random object. Alright, nothing particularly complicated, just new random, okay, and that makes it available. How you access it is game1.rand, and then after that you can actually put what method you want. Now, I'm not going to use it in this code, but just so you can see, there are a variety of different random options. So if in here, because it's in this one, I just need to use rand. Game1.rand. Okay, you will see, okay, you've got next, which will give you an integer. Alright, next bytes, which will give you obviously in bytes. Next double. Alright. When you use next, there is a couple of options that you can add to it. Okay, so if you put next 100, okay, that will give you a random number between 0 and 100. Okay. If you put next 50, 100, alright, that will be a random number that is between 50 and 99, okay, whole numbers. So you can set a range of values, you don't just have to do it as a single one. Next bytes is not really a lot of use to us, to be honest, but next double, okay, all you can specify is next double. You can't put a range in next double. Okay, so be aware. Right, so that's pretty much it. As far as I'm concerned, this gives you at least some basic randomness that you can incorporate into your game. Certainly it's quite useful for randomness of enemies firing bullets. It can make things a bit more interesting for the player. Instead of knowing automatically that the enemy's going to fire every tenth of a second or whatever it happens to be, is a bit boring. You want something unexpected to happen. Movement is useful as well. So, just bear in mind what you're playing about with really is the direction property of your enemy. Okay, and remember, this all comes from Abstract Sprite. Okay, we've got all these facilities in Abstract Sprite that allow us to do these things. We've got things like, you could even randomly change its colour if you wanted to, I suppose. You can certainly randomly change its position and its direction, although positioning might be a bit of a problem. Okay.